We hope you have enjoyed your TLC Mathcation. Whether you completed the K5 version on addition and subtraction or the 3-5 version focused on multiplication and division, one thing is for sure. You're probably now thinking, how do I assess fluency? During this Mathcation session, we will hang 10 and share 10 things we really want you to think about when assessing fluency. As always, remember to connect with us via Twitter and use hashtag TLCMathcation. The purpose of assessment is to be able to make the best informed decisions for our students. This allows us to better plan instruction and move students along the learning trajectory in a way that allows them to build a conceptual understanding of a concept, know how to apply the concept in various situations, and be able to make sense and utilize the relationships between concepts. Before you begin your Mathcation on assessing fluency, we would like for you to open your Jamboard and reflect on a few questions. Be sure to add your thoughts to your Jamboard using the Post-it note feature. Welcome back, Mathcationers. When reflecting on what fluency assessment is, you may have considered how you might assess students differently, or what is the true purpose of the assessments you are giving and how they are used. You may have thought about how you could use your instructional time to gain a deeper understanding of student knowledge instead of time spent for a designated assessment. All of these reflections are meaningful, and it is our hope that during this Mathcation, you have ideas that are grounded from research that support or shift your thinking when considering fluency assessment. Sometimes our assessment of concepts and the assessment of students' understanding of how these concepts are related are disconnected in our practices. This leaves students with a misunderstanding of what mathematics truly is and how to use their knowledge in meaningful ways. When we think about fluency assessment, it is important that our assessment is not focusing on these ideas. While these may be common practices, research has shown that they have an ineffective outcome on students learning facts and carrying this knowledge across grade levels. During this Mathcation, we will discuss what it means to productively assess fluency, different instructional practices that can be used, and understand the various aspects of a mathematically proficient student that needs to be considered. And in good old surfer fashion, we have created a Hang 10 version to maneuver productive fluency assessments with your students. These ideas are the short board version to support you after you have taken your hashtag TLC Mathcation. As we begin our journey, let's consider how fluency is defined. This will help to support our learning as we surf the waves and discuss assessment. Fluency is when you are able to compute accurately, efficiently, and flexibly. Automaticity is knowing without having to think about a strategy, often solved within 3 seconds. Procedural fluency is knowing a strategy well enough that a procedure is fluent for the student. The procedure does not have to be the standard algorithm. It could be a derived fact or even an invented algorithm. Fluency consists of a comprehensive understanding of numbers and their relationships. When assessing fluency, all 4 of these components must be included in the assessment. This ultimately impacts our understanding as educators, the instructional decisions we make, and our assessment practices. Now that we have identified the components of fluency, let's briefly discuss automaticity. Often in instruction and assessment, there is confusion between automaticity and fluency. Automaticity is not the same as fluency. Knowing a fact in 3 seconds or less does not mean that a student is fluent. It is important to know and realize that these ideas are vastly different. When our standards indicate fluently, automaticity is not what is expected for mastery, understanding, or the assessment of fluency. Throughout our Mathcation, we will explore the different aspects of fluency and how these could be assessed in order to gain a robust understanding of students' fact fluency. Before we dive into assessment, let's take a moment to reflect and think about fluency instruction, as this is the foundation for assessment and where authentic opportunities to gather student data occur. Pause the video now and visit your Jamboard. Read each quote and leave a comment. Be sure your response includes an explanation. Welcome back, Mathcationers. As you searched around the quotes and made connections to instructions, it's important to remember that fluency understanding is built on conceptual understanding. When we think about fluency assessment, it is more than students just knowing facts, but also their ability to use them. This is why solving tasks and word problems are a critical component to fluency instruction and assessment. These experiences help students make connections between what they know and how to use this knowledge in meaningful ways. Just like surfing, think about all the problem-solving strategies a surfer must know and be able to use in order to surf. It is so much more than just having a surfboard and a wetsuit. So let's go ahead and take a look at a few examples of student work from a problem-solving task. When looking at these images, there are different mathematical ideas you may notice. In just a moment, we will pause the video and use these student work samples to think about fluency assessment. On your Jamboard, there is a K2 student work sample and a 3-5 student work sample. Choose the student work that best meets your grade level. Think about what the students are able to do and how you might use this work to assess fluency. Welcome back. When students use models and representations to showcase their thinking and reasoning, many strategies can arise. Counting, doubles, near doubles, or even the properties of operations. During tasks, we can assess fluency by determining how students are using their knowledge of facts and strategies. Here are some ideas to consider. As you think about these questions, remember that as you confer with students during tasks, you should be documenting their understanding. Research has shown that students' abilities to think about numbers in flexible ways is an integral part of fluency development. In just a moment, pause the video and consider how a fluent student might solve this problem. After reflecting on the problem, head over to the Jamboard and respond to the questions. Welcome back. Fluency is when a student has multiple solution paths and is able to choose an appropriate strategy for a particular problem. When solving 1003 minus 998, students should easily realize that they can determine that the difference is 5 by reasoning how far away it is to jump from 998 up to 1003. It is important to note that it is not necessary to use formal procedures to solve this problem. Often when students use a formal procedure, more errors occur in their calculation. If students solve this problem traditionally, we must pause and think about whether they are fluent or do they have a procedural understanding. Additionally, a student might use the inverse operation to solve. This is exactly what we want students to do. We want them to understand and know how to use the relationship between operations when solving problems. Regardless if the problem is 1003 minus 998 or 13 minus 8, the strategy and understanding of number relationships remain the same. When assessing fluency, it is important to keep in mind how students are thinking about numbers in flexible ways, which might deviate from a traditional procedure to compute. However, using number relationships is at the core of flexibility. Just like when you choose a resort for a vacation, you might look at the amenities, or what the beach looks like, or how many pools are on the property. All of these can be seen from a different point of view, and each vacationer values them differently. When we think about assessing flexibility, this prompt is one perspective that can be used in the classroom. This can be used as an exit slip, a warm-up, a one-on-one conferral, or even in a whole group discussion. Just like the choice of different resorts for a vacation, students may choose a variety of strategies and think about numbers in many different ways. The different pathways students choose is where assessing flexibility is found. A part of fluency understanding that is tightly aligned with flexibility is appropriate use of strategy. When students solve a problem and have the ability to determine which strategy is the best for their solution process, showcases their understanding of flexibility and number sense. These are critical components to fluency understanding. Researchers have studied students learning math facts in two different ways, one through the lens of memorization and the other through strategies. They found that students who learned facts through strategies achieved superior performance and showed a better transfer of knowledge to new problems over those who memorized facts. When we reflect on fluency assessment, it is important to remember that our standards and research have separated memorization from fluency understanding. When determining assessment opportunities for appropriate strategy use, our questioning can play an important role in this understanding. Asking students to explain orally and/or in writing can give us insight into how students solve and whether they are thinking flexibly or using an appropriate strategy. Take a minute to think about the questions on this slide. How do they help you as the educator assess strategy use? Determining if a student is efficient when solving a problem can come in many different forms. The key to determining efficiency is knowing that there are many different solution pathways to solve a problem. We want to support students in choosing a strategy that moves them along the learning progression. Counting or skip counting might be accurate, but depending on the problem, it may or may not be efficient. When determining efficiency as a part of assessing fluency, we must remember that what is efficient for one may not be efficient for another. And depending on the problem, one strategy for one problem may be efficient, but that same strategy on a different problem may not. This is why students must have many experiences solving various types of problems using a variety of strategies that they choose to use. Let's take a look at these student work samples to solve 8 times 2 and 4 times 100. We can see here that students used different strategies to solve the problems. Pause the video and take a moment to think about what you notice about the student work. Are any of these students fluent? How do you know? If not, what are they working on to gain fluency understanding? Let's take a look at each piece of student work and unpack the student thinking as it relates to assessing fluency. Timothy accurately skip counted. Although he was accurate, he had an appropriate strategy. This is not the most efficient strategy for this problem. It is important to know that it is acceptable that Timothy solved the problem this way. However, from this solution process, we cannot indicate that he is fluent with 8 times 2. Whereas Elise used the commutative property and her knowledge of doubles to solve and reason about the problem. Her reasoning justifies that she used an efficient and appropriate strategy. She was accurate and she was flexible with her numbers. She knew that 2 times 8 is the same as 8 times 2. Sherry used the concept of doubling and halving to reason about 8 times 100. Sherry's thinking was efficient as she did not get lost in the steps when explaining her thinking. She had a clear path to the solution. Sherry's reasoning demonstrated her ability to think flexibly about her numbers and their relationships. She used both of those appropriately in her problem-solving process. Although Sherry and Elise used different strategies and thinking, they both fluently solved the problem. When you shift from speed and memorization and focus on efficiency as one of the pillars in assessing fluency, you value students' ability to use strategic thinking to solve a problem, without being hindered by unnecessary or prescribed steps in the solution process. When thinking about fluency understanding, assessing accuracy used to be the only pillar that was assessed. While accuracy is about whether the answer is correct, research indicates that it is more important that it includes the student's ability to understand if an answer is reasonable and how they explain and justify the reasonableness of their answer. This can only occur if fluency is integrated with understanding, which includes number sense and operation sense. Therefore, when we consider assessing fluency, we need to be mindful that being fluent includes much, much more than the right answer. We have surfed through understanding the 4 components of fluency and looking at what these may look like when assessing students. It is important to remember that in order to properly assess fluency, all 4 of these components must be addressed in our assessment practices. Now that we have discussed the pillars of fluency, it's important to discuss how fluency can be documented. Just like swimming, there are different types of strokes you can choose. And the conditions of the water might just depend on what stroke you chose. In the same way, there are many different types of assessments you can choose to assess fluency. Keep in mind that as we determine if a student is fluent, we should be looking at a comprehensive understanding over time, and if all 4 parts must be present over time in order to be fluent. Here's one example of an observational checklist that can be used to document fluency during the learning process. This could be used while students are engaged in a task, word problems, a game, or even charts from a number talk. This particular documentation form allows you to record the components of fluency understanding that a student is demonstrating, and when used over time, it can show the patterns of the student understanding or gaps they may have. For example, you can see if a student is consistently showing flexibility but may not be accurate, or if they have the same strategies such as make 10 each time they solve a problem. These patterns will support your instructional decisions to ensure that your students have a comprehensive and robust understanding of facts. When looking at this piece of student work and thinking from a number talk, what information can you gain from students? Take a moment and think about how you might record student thinking. What information is evidenced? Take a closer look at how you might use this information from a number talk to document fluency understanding. When documenting fluency understanding, another suggestion that is recommended is to code student work samples or anecdotal notes that document fluency concepts. This allows you to determine if a student showcases fluency understanding across multiple learning experiences and if all 4 tenets or pillars of fluency are evidenced. Here is an example of possible codes that you might use to document student thinking. When conferring during tasks, problem solving, games, or even number talks, these codes can be used to help you to identify which concepts students are fluent and which concepts they are working on. The important thing to remember about coding is that it has to make sense to you. These are just a few ideas to get you started. Pause the video and take a moment to think about how you might code the student work from a number talk. What concepts are evidenced and where are they? Here you can see how you might code student thinking from a number talk. This same idea can be implemented during tasks, gallery walks, and even when conferring one-on-one with students. Now let's surf on over to writing and reasoning. When a surfer calls double up, they are indicating that there is a small wave followed by a large wave, which can result in one big wave and can be totally unrideable. But under the right conditions, it might also provide the biggest, widest, and best ride of a surfer's life. In mathematics, writing and reasoning play this same role. Under the right conditions, as students reason and write about their thinking, this can provide some of the best insight into student understanding of number relationships and the strategies they use as it relates to fluency. When we provide students with purposeful opportunities to write during tasks, word problems, and games, we organically present an excellent opportunity to assess fluency. This provides us insight into students' flexibility with numbers, understanding of a selected strategy, and application. From pre-K and beyond, reasoning and writing are a necessity in mathematics and are a critical component to authentically assess fluency. Consider the problem 4 plus 5. What might your students say if you presented the following problem and asked them how they might solve the problem, instead of asking, what is 4 plus 5? What information might you gain from students? When we ask students this type of question, we gain new perspectives. We immediately engage students in reasoning and justification. And then we learn a lot about their understanding and application of knowledge in their response. Some students might write, say, or draw a picture to show how they counted to 4. Another student might decompose 4 to 2 and 2 and skip count from 5. Or a student might use a double, such as 4 plus 4. And some students may even use an inverse operation and relationships to show their understanding, such as take 1 away from 10 and that is 9, and I know that 5 and 5 is 10. All of these ideas highlight various strategies and levels of understanding. These responses give us so much more information to support our students' fluency understanding than simply asking, what is 4 plus 5? For students who might struggle with facts, we also just opened their mindset that there are many possibilities and pathways to a solution. This gave them the confidence and built the awareness that you are interested in a pathway that they might choose rather than their answer. Gameplay should also be immersed with reasoning and writing components where students record their thinking, strategy used, and communicate their reasoning. The reasoning and writing associated with gameplay is a great way to assess fluency. As students play games, listen to what strategies they are using and ask lots of questions. Using questions like these can provide you with a deeper understanding of student thinking. When playing games, it's important to remember that assessing fluency should be done after the game has been played at least one time. Because what research says is the first time you play a game to learn the rules. You may not quite be ready to be thinking about the strategies and strategizing when it is your turn. Once students have had the experience of playing the game, use it as an opportunity to assess fluency as students apply their knowledge. Research shows that one of the best forms of fluency assessment we can provide is to ask students to write and create their own story problems from a given number or numbers and/or operation. When students are writing story problems, they are often thinking about the relationships between numbers and the operations. In addition, they are taking a decontextualized problem such as 2 times 6 and contextualizing it into a story problem. All of this works together in order to provide insight into student thinking, flexibility, strategies, efficiency, and accuracy. When using a student-generated problem for assessment, consider these components of fluency and how these students apply their understanding in the writing and solution process. You will be amazed what you learn about your students and their relationship to fluency by just writing story problems. Let's surf into relationships, number sense, and the connection to assessing fluency. Research supports that relational understanding is at the heart of fluency development. If a student uses addition to solve a subtraction problem, that does not indicate they were not fluent. In fact, there might be a greater argument that they were fluent with that fact. because they were able to use the relationship and think flexibly to solve the problem. Think back to our example of 4 plus 5. If the only connection a student has to 4 plus 5 is a memorized fact, there are less examples for the student to build upon. The power behind developing number sense in order to build fluency is that a student might think about 4 plus 5 as this. Look at all the ways students are thinking differently about numbers. Developing number sense and relationships between operations plays a role in determining what facts students know and are able to use, ultimately supporting fluency development. As we surf in on our last board, let's continue the conversation and focus on fluency assessment and math anxiety. In just a moment, you will pack up and head over to the Jamboard, where you will find a link to an article about math anxiety and fluency assessment. Prior to reading the article, respond to the question on the Jamboard. After reading, post your response on your biggest aha from the article. We hope you had some great aha moments. The article highlighted math anxiety, shifts from timed tests to more productive learning opportunities, and the impact on students' mathematical mindset. In reflecting on assessing fluency and all that we have learned, think about how you can shift your thinking from time tests to spending your instructional time focused on number sense and conceptual understanding. Take a moment to read the following quote. This quote resonated with us when thinking about fluency development and assessment. Think about what this might mean for the changes you can make in your own classroom. There are a few key ideas to fluency assessment and student learning that we hope fit in your suitcase as you travel back to school. As you plan fluency assessments, continue to think about how the assessment will provide a comprehensive understanding of student thinking. How might students make sense of problems in ways that highlight the 4 components of fluency? And how might your students use relational thinking and number sense? When we think about these ideas during the planning process, we will adequately assess students in meaningful ways. As you scroll through your Mathcation photos, we hope that one picture you can keep in mind, and that is assessment is one snapshot in time. Your data and documentation should showcase how each student is efficient, flexible, accurate, as well as have appropriate strategies when solving problems. Just think, after you hang 10 with these ideas and catch some great waves in the classroom, you will have a variety of strategies and moves to assess fluency.